So cyber drunkenness, what is this? It's really speaking to a lot of terms that we've referred to as simulator sickness, cyber sickness, motion sickness. We heard it earlier today called seasickness that's associated with VR. This is a range of symptoms that's associated with both during and following exposure to virtual environments. I'll also speak to design guidelines to prevent VR sickness. Now, this is a topic that's much closer to VR than AR or MR, and that may be because there's a lot more information, a lot more studies, many decades of research in that area, and we're just starting to scratch the surface with what happens within AR environments. So as Oculus VR CEO said a few years ago now, the elephant in the room is disorientation and motion sickness. 3 years later, that's still the case, absolutely. How big of a problem is it? I want to take a quick audience poll. How many people have experienced cyber sickness previously? Big hands up for me too. So susceptible individuals represent 50 to maybe 95% of the population. That's based on thousands of individuals we've run in our own lab and a worldwide and growing literature. Susceptibility differs based on gender, age, previous experience in VR, even race and ethnicity. But those who are susceptible can experience visual flashbacks, oculomotor disturbances, or really changes in eye movements and saccades and increased nystagmus. Nausea, vomiting is relatively rare actually. Disorientation is very common, as is excessive sleepiness, precipitated by a lot of yawning and the so-called sopite syndrome. So what you'd see here is a lot of similarities between drunkenness with alcohol and individuals exiting VR in terms of vestibular changes, changes to proprioception, changes to balance and movement, such that we've begun to work with a blood alcohol equivalency that's associated with exiting a VR environment. So the question is, physiologically speaking, my background is in biomedical engineering and neuroscience. Can we really cope with VR exposure now? And the answer is not yet, at least for many people. And why is that? So the way our sensory systems have been designed and over many eons have adapted is that vestibular input, visual input from the eyes, et cetera, proprioceptive input, all act in synchrony to help us to be able to move throughout a three-dimensional environment, to interact, to find, et cetera. What happens in VR is that these systems become dissociated such that visual input, highly realistic visual input, doesn't have associated vestibular input. We're not feeling the movement within our inner ear and the otoliths, et cetera. And that causes cybersickness, and that's one of the big theories in terms of why this is occurring. Previously, there were a lot of system imperfections that caused a lot of problems. These are actually starting to get better. Let me go back, actually. I hit the wrong button there. And I'll speak about a few ways that is getting better. However, as I've already mentioned, there is vestibular and visual conflicts, somatosensory conflicts as well, because we're really not bringing in the proprioceptive inputs. And the Virgin's accommodation conflict really speaks to how our eyes can work in a three-dimensional environment. We're asking in VR the eyes to be able to see in depth and to be able to change where we're focusing. But we're really talking about a screen that's a couple of centimeters away from your face, and so that really forms this Virgin's accommodation conflict. All of this acts together to cause symptoms during VR exposure, such as disorientation, nausea, oculomotor disturbances. Now, alarmingly, these effects can also continue after you've exited VR. Postural instability, many of you have probably experienced that, altered eye movements, headache, general malaise, altered hand-eye coordination. Again, you see a lot of overlap between the standardized field sobriety test here and the after effects that we've seen post-VR. So in our studies, and I mentioned in our lab, we've run many thousands of individuals through VR-based studies, and we've identified that, and this is a very interesting study, 2-hour VR exposure, completely passive, sitting in a virtual theater, just watching a movie. We found that on average, upon exiting, it took individuals more than an hour to return to their baseline VOR. So these eye movement changes lasted for an hour at least afterwards. The hand-eye coordination after effects, the postural stability, which much longer. And in many cases, individuals continue to report malaise, nausea, headache, et cetera, even 24 hours after exposure. And this is represented by a couple of hundred participants in a large study for a content developer. So, as I mentioned, there's some technical improvements that have occurred in the current generation of symptoms that are reducing cyber sickness, and these are great things. One is that the head tracking has gotten much better, clearly, and many of you have worked with developer kits and done yaw type of movements, and when what you're seeing on screen doesn't match what your vestibular system is telling your head in terms of its rotational acceleration and movement, that can cause intense, instant cyber sickness. And frame rates are increasing, and that's a good thing as well. Slower frame rates in the past have contributed to latency and jitter. That increases cyber sickness. And one kind of take-home message, and what we found and many others have reported, is that inconsistent frame rates are far worse than just having a lower frame rate and keeping that consistent. That prevents adaptation to the environment. So another take-home message. However, cyber sickness still occurs even with the current generation of systems in 2014 and today in 2017. It occurs when you take away viewpoint control from the viewer. I'm going to underline this, call this the cardinal rule. Never take viewpoint control away from the viewer. Don't camera pan, you cause viewpoint panning, tilting, etc. without physical motion of the head. Visual acceleration, whether that's linear acceleration, angular accelerations without concordant vestibular stimulation, are very problematic. I've already referred to this. Discomfort increases as a function of the frequency, size, duration. It's also quite different across different degrees of freedom, some of which are much more nauseogenic than others, especially backward acceleration. Think about driving your car in reverse. Note also that the vestibular systems are phasic systems in terms of the receptors. They really respond to changes in acceleration, not constant velocity, such that constant visual motion is much less problematic than changes in acceleration. And that's true for, again, both angular acceleration or linear. The degree of control is a big issue here. Imagine being the passenger in the car versus driving the car. If you, again, are the passenger, that can be much more problematic and nauseogenic. Implementing shaking or bobbing viewpoint that would be associated with mimicking walking is definitely nauseogenic. Unusual maneuvers, I already spoke to backward acceleration. Off vertical axis rotation, also highly nauseogenic. Optic flow, and this is really associated with, as the field of view has continued to increase with the current generation of systems, vection has also increased, and that leads to even more cyber sickness than previous generation of devices. As we've compared the previous generations being in this field for 20 years, we've actually seen the current generation potentially being the most potent in terms of nauseogenicity. So what can we do to reduce the incidence of cyber sickness with the current generation of systems? A number of things. Again, I've already kind of spoken to providing vestibular and visual input together. That can be done with a motion base. VR Coaster is doing this across Europe. These are starting to be implemented across the Six Flags theme parks in the US, essentially a roller coaster with a VR device. Implementing peripheral blur is very helpful as well. That reduces vection, especially as you have higher fields of view. And providing a dynamic field of view, which is much more close to a naturalistic viewpoint. And this is generally done by integrating eye tracking, like the FOVE system or many others. Oh, went too many. Here we go. Go back one slide. So postural maintenance, this is really giving an individual an idea about what's going to happen on screen prior, so they can, for instance, lean into a turn. An example here at left with a virtual coaster, you can see, versus the one on the left has this very bright blue that's associated with the track, such that the individual knows to lean into the next turn, lean back, etc. That allows them to maintain posture. It reduces the types of head movements that are associated with adding weight to the head from these devices and reduces cyber sickness. Again, the cardinal rule, not taking away viewpoint control. And in cases where individuals are not in control of the motion, in the example here where they're at the right and the person on the left is driving, providing them some sort of physical leading indicator such that the steering wheel moves as the other person moves the steering wheel can also support movement predictability. Also, providing rest frames is very helpful, whether that's done in the foreground by providing a cockpit such that there is a stable interface that they can look at, or doing that in the background, for example, in this racing simulator by providing a locked horizon. We've also seen a lot of utility by including a virtual nose, as is shown on the right in this roller coaster, that actually can sufficiently reduce cyber sickness incidence and prevalence. So at Design Interactive, like I've mentioned, we've been doing this for 20 years. And when we take a look at new content, new hardware, new rides at the theme park industry, et cetera, we look across multiple parameters. We started to speak to a few of these. We look at the content itself. How long is the exposure duration? As that increases, the incidence of cybersickness increases, as does the prevalence and length of those symptoms. We look at the content. We look at visual parameters such as frame rate and tracking rate, which we already spoke to. We didn't speak to contrast ratio, brightness, screen resolution. This becomes even more important in AR. We look at the field of view and HMD design. When motion is involved, we looked at visual motion and visually induced motion sickness, and we look at the axes of motion when you start to add a motion base. Effects of oscillation, I spoke to the fact that some degrees of freedom are much more nauseogenic than others. That's true for specific oscillations, such as in the 0.1 to 0.5 hertz range. We look at g-forces. Human visual constraints like matching the IPD. There's a lot of individuals we work with who are interested in using this in children, and matching that IPD becomes extremely important. And of course, the visual, vestibular, somatosensory mismatches and effects of virtual object location. And I started this talk talking about some human physical constraints like height, age, gender, etc. We always look at that. But environmental factors we found to be extremely important, such as temperature and humidity of where the experience is occurring. And at the center of this, of course, is the human and their effects in terms of disorientation, oculomotor, and nauseogenic effects. So with that, I'm going to close, and thank you for your time.